Hey guys, Mr. Mackey here. Now yesterday I introduced you to probability and I gave you some examples on how probability can be used in everyday life. And I set you this challenge where I tossed a coin twice and I wanted you to tell me what the probability of after tossing that coin twice, I would get two tails. Now this might be a bit difficult to kind of think about because finding out with one coin that there's only two possible outcomes, heads and tails. How many outcomes could there be if you toss a coin twice? Now this is why we're going to be using our first method of laying out probability today, and this method is known as a sample space diagram. Now what this sample space diagram represents are all the different outcomes you could get if you're doing something more than once. In this case, this area is going to represent coin number 1, and this is going to represent coin number 2. The H represents heads and the T represents tails. So let's say that for coin number 1 I got a heads, and in coin number 2 I also got a heads. That means that overall I got 2 heads. What about for coin number 1 if I got heads, but for coin number 2 I got tails? Then my outcome would have been a heads and a tails. For coin number 1 if I got tails the first time but then heads the second time, it would be tails and then heads. The reason why I rubbed it out just then was just to make sure you guys understand that it was in that order that I got them. And then for the final one, if I got tails on that one and tails again, it would be 2 tails there. And that's what we're looking for. So overall, the number of outcomes that could happen are 4. You could get 2 heads, you get heads the first time and tails the second time, tails the first time, heads the second time, or 2 tails. So there's 4 outcomes. And how many of those outcomes do I win? Just once. Because it's 2 tails. So the probability that I would get 2 tails is 1 out of 4. Which is fairly unlikely. Because even though it's still possible it could happen, it's more likely that one of these other 3 events could occur. Now let's look into a bit more detail on sample space diagrams. Here's a good example. A dice roll. Let's say that I was to roll this dice twice and I added together the results I got when I rolled this dice. Let's do it now. So I roll it once and I got a 5. Let me roll it again and I got a 2, and I added them together and I got 7. What was the probability that I would have got that 7? Now this is when we're going to need a sample space diagram again, but how would we label it? I'll show you. It would look like this. Now this would be dice number 1, with numbers 1, 2, 3, 4, 5, 6, and this would be dice number 2. So let's say for example in dice number 1 I rolled a 3 and dice number 2 I rolled a 2. So I added them together, line them up, and you would get a 5. But I'm not looking for a 5. I'm looking for the number of times I got a 7. So let's find them. There's 1 here, 2 here, 3 here, 4 here, 5 here, and 6. There's 6 7s on there. How many outcomes are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36 different outcomes, all in one breath. Blimey. So, out of 36 outcomes, how many of them do I win? I win if I rolled a 7. There's 6 7s on here, so the probability is 6 out of 36. But what have we always done about fractions? They can be simplified. So how can we simplify this? Well, we divide it by 6. So the probability that I would have rolled a 7 when simplified is 1 over 6. Let's try another one. I'm still going to do the dice rolling, so I'm going to keep this sample space because there's so many probability questions we can get from this. What is the probability that if I roll this dice twice and add up the totals, I will get a number greater than 7. This one will be a bit different because we're not looking at just a specific number in this. We need to look for numbers that are bigger than 7. So there's 1 here, 2 there, 3 there, 4 there, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 numbers bigger than 7. How many possible outcomes are there? Well, we've just worked this out. There are 36 different outcomes. So, out of those 36, how many of them will I win? Well, there's 14 different possible outcomes that I'll win. So it's 14 out of 36. But this can still be simplified. We can divide them both by 2. So the probability that I will win by getting a number bigger than 7 is 7 out of 18. Simplified, obviously. Not bad. So I roll my dice. What is the probability that my total is less than 3 but greater than 10? So I want to know the probability that I roll, that I score a total that is less than 3 or it's greater than 10. So there's only one number that's less than 3 here, and that's 2. And there's 11 and 12 here. So if I got any of those 4 options, I would win. So out of those 36 options, only 4 of them will guarantee me a win. Simplify that, it is 1 over 9. Now that's fairly unlikely that that would happen. Let's try it now. The first number I rolled is a 5. The second number I rolled is a 4, which makes 9, so nowhere near. See how unlikely it is? So here's one for you to do at home for your challenge. I roll a dice twice. And with the results I get, I multiply them together. So let's say I roll this dice now and I rolled a 2 in the first roll and a 3 in the second roll. I multiply them together, which means the answer I got was 6. I want you to make a sample space diagram like this one with all these outcomes listed. And then I want you to find for me the probability that I would score a 12 after multiplying. And then I want you to find the probability that I would have gotten an answer bigger than 30. Those are your, that's what you need to do. Let's see how you do it. I'm looking forward to seeing how these sample space diagrams go. Let's bring on more probability week tomorrow. Good luck. Have a good evening. Let's keep on learning.